Alright, in this video we're going to be talking about the binomial distribution. So if you have a random variable, for example x, that satisfies the four following conditions, that it has two outcomes, probability of success is constant, we've got a fixed number of trials, and all these trials are independent of each other. Then we can say that random variable follows a binomial distribution. So if this random variable is x, then x follows a binomial distribution with the parameters n, where n is the size of the sample and p is the probability of success. If this sounds a bit abstract right now, don't worry, we're going to do a few examples just after this. And if we want to find the mean, the expectation of x under a binomial distribution, that's going to be np, and the variance or var of x, that's going to be np times 1 minus p. And in some literature you may see 1 minus p being written as q. Alright, so this formula might appear as var of x is equal to npq. And to evaluate probabilities under a binomial distribution, we use the formula, the probability that x is equal to r, where r is a trial, that's going to be n choose r times the probability of success raised to the power r times the probability of failure raised to the power n minus r. And again, you might see 1 minus p as q. Alright, so now let's actually dive in and look at some examples and do something with this information. Here we're given that in a certain large college, 22% of the students own a car. Part A says 3 students from the college are chosen at random. Find the probability that all 3 students own a car. So we can define a random variable. X is the RV, and we can say this is the number of students that own a car, number of students who own a car at this certain college, right? And so according to the way we've defined our random variable, x is going to have two outcomes. Either the students own a car or they do not own a car. And the probability of success of a student owning a car is going to be constant. It's always going to be 22%. And the number of trials in this case is 3 students. And since these are random, the trials are going to be independent of each other. The outcome of one trial is not going to be affected by the outcome of another. So we can tell that x satisfies the 4 conditions for a binomial distribution to be suitable. So as a result, we can say that x follows a binomial distribution with n is 3 and the probability of success is 22%. Never write your probability as a percentage, rather give it as a decimal, so 0.22. And we want to find the probability that all 3 students own a car. So we want to find the probability that x is equal to 3. So using the formula for binomial probabilities, that's n choose r, so 3 choose 3, multiplied by our probability of success, 0.22 raised to the power 3, multiplied by 1 minus our probability of success raised to the power n minus r, so 3 minus 3, so 0. So this means the probability that x is equal to 3 is equal to, punch this into the calculator, that's 3 choose 3 times 0.22 cubed, and that gives us 0.0106, and that's our final answer for part A. Let's look at part B. Now we've been given that 16 students from the college are chosen at random. Find the probability that the number of students who own a car is at least 2 and at most 4. So we're still investigating the number of students who own a car, except now they've changed the sample size from 3 to 16. So let's define another random variable for that. So let's maybe call this random variable y. So RV, number of students who own a car at certain college. And again, because this is technically the same random variable, is x, all 4 of our conditions are satisfied. There are 2 outcomes: either the student owns a car or they do not own a car. The probability of success is still 22%, so it's going to be constant throughout our trial, and we have a fixed number of trials. In this case, that's 16, and our trials are independent of each other since our trials are random. Okay, so we can say that y therefore follows a binomial distribution, and the sample size or the number of trials is 16, and the probability of success is 0.22. And we're required to find the probability that the number of these students who own a car is at least 2 and at most 4. So this is the probability that at least 2, so that's greater than or equal to 2, and at most 4, less than or equal to 4. So it means we're evaluating the probability that y is equal to 2, 3, and 4. So let's do that using binomial probabilities. Let's start with the probability that y is equal to 2. That's going to be n choose r, so 16 choose 2, multiplied by the probability of success, 0.22 raised to the r, so raised to the power 2, times probability of failure. So let's just calculate probability of failure. Q is 1 minus p, so 1 minus 0.22, so Q is 0.78. So this is 0.78 raised to the power 16 minus 2, so 14, plus, alright, so this was y is equal to 2. Now let's move on to y is equal to 3. That will be 16 choose 3 multiplied by 0.22 to the power 3 multiplied by 0.78 to the power 13. And now let's move on to the probability that y is 4. So this becomes plus 16 choose 4 times 0.22 to the power 4 times 0.78 to the power 16 minus 4, that's 12. This is the probability that y is equal to 2, 3, and 4. Let's punch in each expression into our calculator. So let's start with 16 choose 2 multiplied by 0.22 squared times 0.78 to the power 14. That gives us 0.179205, 26 decimal places, plus 16 choose 3 times 0.22 cubed plus 0.78 to the power 13. So that's this expression, and it gives us 0.235877 to 6 decimal places. And let's evaluate the last expression. So that's 16 choose 4 times 0.22 to the power 4 times 0.78 to the power 12, and that gives us 0.216221. And let's add up all of these results. So this is the probability that y is equal to 2, 3, and 4. So that's 0.179205 plus 0.235877 plus 0.216221, and that gives us 0.631, and that would be our final answer. Let's look at one more example of the binomial distribution. Here we're given that company A produces bags of sugar. An inspector finds that on average 10% of the bags are underweight. 10 bags are chosen at random. Find the probability that fewer than 3 of these bags are underweight. So let's start by defining our random variable, and let's call it B since we're talking about bags. Let B be the RV, number of bags that are underweight. We're looking at bags that are underweight. So number of bags that are underweight. So again, you check, does this random variable satisfy all 4 conditions that you have? That's to say, does it have 2 outcomes? Yes. We're checking whether bags are underweight or not underweight. And is our probability of success constant? Yes, because it's 10%. And then our trials, we've got a fixed number of trials, we've got 10. And then our trials are random, so they're independent of each other. So it means that B follows a binomial distribution with our sample size or number of trials being 10, probability of success is 10%, so 0.10. Now a key, just so that you know whether it's binomial or not, usually when they say 10 bags are chosen at random, whenever you get this expression 10 bags are chosen at random, let's go back here to the previous question. We can see here we had 16 students from the college are chosen at random. 3 students from the college are chosen at random. Usually when you get that sentence that this is chosen at random, it means that your random variable is probably binomially distributed. So to save you some time, once you see that sentence, start thinking in terms of the binomial distribution. So we want to find the probability that fewer than 3 of these bags are underweight. So we want to find the probability that B is less than 3. Fewer than 3. So less than 3 would be the probability that B is equal to 2, it's equal to 1, and it's equal to 0. So let's evaluate all of these probabilities, starting with B is equal to 2. So that's going to be 10, choose 2, multiplied by 0.10 to the power 2, and Q is going to be 1 minus 0.10, so Q is 0.90. So this is times 0.90 to the power 8. Okay, and then that's 2, so let's evaluate 1. 1 is going to be 10, choose 1, multiplied by 0.10 to the power 1, multiplied by 0.90 to the power 9, plus, let's do 0, that's going to be 10, choose 0, which is the same as 1, multiplied by 0.10 to the power 0, which is going to be 1 as well, multiplied by 0.90 to the power 10. Alright, so for B is equal to 0, what you notice is that this is technically 1 times 1 times 0.90 to the power 10. So in general, what we can say for Q, when you've got a random variable x, right, and you're evaluating x is 0, we can say in general this will be Q to the power n. So you don't necessarily have to show this part, okay, because it's going to be 1 times 1. Okay, and this idea may be useful in solving other problems. Alright, perfect. So now let's punch this into the calculator. The probability that B is equal to 210 is equal to, let's start with probability that B is 2. That's going to be 10, choose 2, multiplied by 0.10 squared times 0.9 to the power 8, and that gives us 0.193710 plus, let's do B is 1, so 10, choose 1, multiplied by 0.1 to the power 1 times 0.9 to the power 9, and that gives us 0.387420, and then let's do B is 0, so that's 0.90 to the power 10, and that gives us 0.348678. Let's add up all our probabilities to get our final answer. So this is 0.193710 plus 0.387420 plus 0.348678, and that's 0.930, correct, to three significant figures, and that's our final answer. So that's it for the binomial distribution video. Make sure to go through the quiz, and I'll see you in the next video.